All right, so now that you know how to find a composition of functions, we are going to graph composition of functions, which is just as simple as finding a table of values and plotting them on a graph, which is not beyond your realm of possibility, right? Don't freak out. I know how much you love to graph things, but we're just going to go through the process. Okay, we're going to find f of g of each one of these numbers, and these are really the only nice numbers that we're going to have on this graph, and then we're going to plot them. So if we're finding f of g of -3, now remember f of g is f of g of x. So we're really finding f of g of -3. Well, g of -3 is over here, it's 3. So we're really finding f of 3. F of 3 is -2. So this is just -2. And that's it. Now we'll do the same thing, but we'll do it with 0. So we're really finding f of g of 0, which was 0. And f of 0 is 1. So we'll put 1 right here. Last one. Now we're finding g of 3. G of 3 on the graph is 3 again, which we know was -2. So if we plot these points on the graph, then we're going to have -3, -2, 0, 1, and then 3, -2, which makes us think it's looking something like this. And we know what that function looks like. That looks like a v, but it's upside down. So now we're going to talk about a transformation, right? Now we've already talked about 1. So first, f of g of x, it is an absolute value function. It looks like instead of being centered at 0, 0, it's shifted up 1, so we're going to put a +1. And then the way that we're going to flip it is by putting a negative in front. That's called a reflection about the x-axis. That's how you indicate a reflection about the x-axis, by putting a negative in front of your absolute value function. We'll talk more about transformations very soon.